Well, hello, everyone. My name is Heidi Christensen, and I'm with the Partnership Center for Faith and Opportunity Initiatives here at the U.S. Department of Health and Human Services. We are so very glad that you have joined us today for this first in our summer series of 3 webinars focused on the science and practice of community-based prevention of substance use. Over this in the last year, our webcasts that address the opioid crisis focused on the treatment and recovery support of those already using or addicted to opioids and or other substances. Our summer series is an opportunity to focus on prevention, a shorthand term we are using to encompass the work of breaking the cycle of addiction and preventing future generations from harm. Today's webinar presentation, Brain Under Construction, Building Pathways to Resilient Futures, with our friend and colleague, Dr. Ruben Baler at the National Institute on Drug Abuse, or NIDA, will help us understand the latest science on the teen brain, how different parts of the brain develop at different rates, and how that relates to the healthy brain development and how teens can make choices today that could help strengthen their brain as well as their resiliency to meet life's challenges. So we have an exciting and informative program today, and I will more fully introduce our speaker in a moment. But first, of course, a few housekeeping notes before we begin. This is an educational webinar. It is off the record and not intended for press purposes. If you are a member of the press, we will be happy to connect you to the press office here at HHS after the program. While we do have a full program today, we welcome your questions and comments throughout the webinar, and you can place them in the box for questions in the lower right-hand corner of your screen. We hope to share as many as possible with Dr. Baler during the Q&A at the end of the program for his response in the time that may be available at the end of the program. Also, if you are having difficulty with your audio, you may find it helpful to call into the number on your screen rather than to listen through your computer. We've just found that sometimes that just works better for sound quality. And as a final note, we will be sending a link to a recording of today's webinar that we hope you will share with your community in a follow-up email to everyone who has registered, along with the links that will connect you to the wealth of information and resources that the National Institute on Drug Abuse makes available to teens, families, and community leaders. So look for that follow-up email in the next day or two. In her letter to teens, Dr. Nora Volkow, the director of NIDA, noted that 2.14 million people ages 12 and older had an opioid use disorder in 2016, including 153,000 young people between the ages of 12 and 17 years old. We know that many young people are given their first opioid as a pain reliever after a sports injury, surgery, or dental work. In fact, in one study, we learned that the main prescribers for patients aged 10 to 19 years old were dentists, accounting for 31% of prescribers to this population, followed by primary care and then, of course, emergency medicine physicians. We also know that adolescence is a crucial period for initiation and experimentation and the establishment of more regular patterns of use of alcohol and other drugs. And so these drivers, coupled with the critical genetic and environmental components that may predispose more readily some young people to addiction and substance use disorders, presents a precarious road to navigate for the youngest members of our population. And so giving teens, their families, and communities the information they need to be educated consumers of pain treatment and management, and understanding the brain science behind addiction and the development of a healthy brain will help teens make the smart and informed choices that will shape and contribute to a healthy, hopeful, and promising future. So to begin our journey in understanding the brain, I am delighted and privileged to introduce our presenter today. Dr. Ruben Baler, PhD, is the health scientist for the National Institute on Drug Abuse, or NIDA. There, he writes and lectures about the neurobiology of drug abuse and addiction for a range of audiences. He spoke to an auditorium full of national 4-H youth leaders earlier this year and adult volunteers, and he got a standing ovation and was enthusiastically received. So, pulling from diverse disciplines, his work seeks to advance NIDA's scientific mission as it intersects with cellular and molecular biology, genetics, immunology, bioinformatics, neuroscience, and neuroethics. He received his PhD in microbiology and molecular biology from the University of Miami and completed his postdoctoral training at the National Institute of Child Health and Human Development, specializing in molecular chronobiology. Well, we are so very glad to have such an accomplished leading scientist who is deeply committed to the well-being of our future generations with us today. Dr. Baler, we're so very grateful, and I think it's time to turn this presentation over to you.
Thank you so much, Heidi. Can you give me confirmation that you are seeing my screen now?
We are seeing your screen.
Excellent. I hope that the voice and the sounds are okay. Well,
yes.
Welcome everyone. Good morning. Thank you for coming. Let's see. My name, as Heidi said, is Ruben Baler. I work with the Science Policy Branch at NIDA. And before I get started, I'd like just to plug this infomercial, this ad for the National Drug and Alcohol Facts Week that will be running next year in January. But this is timely because the registration for events will start at the end of next month in August. So anyone who wants to learn about this week-long event next year in January can visit our website, teensdrugabuse.gov, and look for materials and instructions how to host an event in your community, in your area. So that's the National Drug and Alcohol Fact Week. It will be running January 22nd to 27. All right. So this webinar, the focus of this webinar is self-regulation and decision-making. We're going to explore what sort of knobs and dials we can tweak to improve a young person's ability to control prepotent impulses and the quality of his or her decisions. These decisions, like what we eat, how we react to annoying coworkers, or spend our leisure time, they come in many flavors. They are going on all the time. Some are big, some are small, but in the aggregate, they shape our life's trajectories, obviously. So it's not really all that surprising that the capacity of a child to self-regulate is such a good predictor of important long-term outcomes. To illustrate the impact of self-control on a child's future, let's look at the results of the marshmallow test. This is which I suspect the vast majority of the audience here is quite familiar with. For those few who may not be familiar with the marshmallow experiment, this is a classic, iconic experiment done in the 60s by Dr. Michel. A young child is given a reward, in this case was a marshmallow, and told that if he can wait for 15 minutes, he could get a second one. So it's in fact, it's a measure of the ability of a child to delay gratification. So this marshmallow experiment and many experiments like that experiment has shown that there is a very strong correlation between early ability to delay gratification and an adolescent achievement and socioemotional skills. More specifically, kids that score higher in the self-control marshmallow type experiments, they also score higher in tests of assertiveness, self-reliance, dependability, trustworthiness. They have higher coping skills, academic competence, and ability to refrain from using alcohol and drugs. Those kids that score lower in the self-control or delay gratification experiments, tests, they're more likely to be indecisive, stubborn, and impulsive. They're easily frustrated, more jealous and envious of others, poorer students with a lower self-image, and had more experience with drugs and alcohol. These type of experiments have been now extended and published. An epic experiment like that was published in 2011. They have been extended in a longitudinal kind of a design for 30 years. These kids that have been measured for self-control in marshmallow-like experiments now have been followed up for up to 30 years. And what these type of experiments show, that there are very powerful links between early self-control and long-term outcomes. In fact, individuals in the bottom 20% of the self-control scale display on average more than twice compared to those at the bottom 20%. That is, those that have a higher self-control as children, they display on average more than twice the prevalence of things like criminal record, having a criminal record, raising children in single-parent households, having an annual income of less than $15,000, suffering from drug dependence, having multiple health problems. So these are the type of key questions, emerging properties that are behavioral in nature that we'd like to get a handle on. For example, why do some students seek to gain competency where others seek to outperform their peers? Why do some athletes redouble their efforts when facing setbacks, whereas others respond with helplessness? Why do some dieters feel confident in their ability to face challenges to their weight loss goals, whereas others feel they lack the requisite skills? Why some kids seem refractory to the most toxic forms of peer pressure, whereas others can't wait to accept the first joint offered to them? There is a mounting amount of evidence, a lot of literature and a lot of data that shows that one of the key components, fundamental components that sits at the bottom really of these processes that are so complex at the cognitive level, these types of decisions and behavioral styles, is something that is being called implicit theories, which is what people think about the malleability of their human attributes. And there are essentially two types of these implicit theories. There are kind of the drivers of behavior that drive people in one way, in one direction or another, and they are mostly subconscious, obviously. One of the types of implicit theories are the incremental types that say that human attributes can be improved or developed. If you're familiar with the work of Carol Dweck, this is what we typically call growth mindset. In contrast, the entity types of theories, of implicit theories, would say that human attributes are fixed or invariant. This is in Carol Dweck's work, what we call the fixed mindset. So there's a lot of studies showing that those who embrace an incremental theory, more or less subconsciously, they tend to seek to gain competency, redouble their efforts when facing setbacks. They tend to feel confident in their ability to face challenges, or are more refractory to the most toxic forms of peer pressure. While those who tend to predominantly embrace an entity type of implicit theory, they tend to seek to outperform their peers. They respond to failure with helplessness, feel they lack the requisite skills, and that they can't really wait to engage in risky behaviors to please others. So we really like to find a knob or a dial to manipulate as early as possible these two very different trajectories that are intertwined with, obviously at some level, with neurophysiological mechanisms. We'd like to nudge individuals as early as possible if we identify these type of fundamental properties in their behavioral styles and try to nudge the person with a tendency for a fixed mindset into a trajectory that is more aligned with a growth mindset. In school, people have been doing that for several years, mostly after the work, as I mentioned, from Carol Dweck. What we're trying to move away in these type of scenarios is from a fixed mindset response to the performance of a kid to a more growth mindset. These are just some of the examples that teachers can engage in. In a fixed mindset environment, when a kid fails or struggles with a particular task, the response will be, not everybody's good at math, just do your best. The growth mindset would say, when you learn how to do a new kind of problem, it grows your math brain. In a fixed mindset, we would say, that's okay, maybe math is not one of your strengths. The growth mindset would say, if you catch yourself saying, I'm not a math person, just add the word yet to the end of the sentence. The fixed mindset would say, don't worry, you'll get it if you keep trying. The growth mindset would say, that feeling of math being hard is the feeling of your brain growing. And finally, you would say, in a fixed mindset scenario, great effort, you tried your best. A growth minded teacher would say, the point isn't to get it all right away. The point is to grow your understanding step by step. What can you try next? So looking at these two scenarios, two different, very different mindsets, I thought that this idea of feeling your brain growing really is an opportunity to enrich content, curriculums in school, to really give the kids some kind of a clue or hints or content, education, and some insight as to what is really happening under the hood, under their own hoods, and some kind of insight as to the drivers of their behaviors, of their tendencies, their responses, and their decisions. So this is what this module that I've been designing for the past couple of years is really all about. It's a teaching module designed to nurture a growth mindset from a perspective of a neuroscientific content. Develop a module, and there are 4 messages in this module that will be deployed at the beginning of the year, for example, And then it can be reinforced through selective use of particular parts of the normal curriculum throughout the year in different disciplines. Could be literature, could be psychology, could be computer sciences, biology, and so forth. So this teaching module designed to nurture a growth mindset is based on 4 pillars. There are 4 main messages that I develop here. One is the message that we have at least 2 brains, not one. The second message is that these 2 brains develop at different speeds. The third one is that the process of this brain development is very similar to programming a computer. And the fourth one is the idea that some things in the environment can compromise that programming. So these are the 4 modules that I'd like to very quickly go through with you and give you a flavor of what I'm talking about here. So the first message is that we have 2 brains, not one. And I'll give you a quick test, and you can do it out loud in your brains, or if you are sitting with somebody, you can just scream the names of these individuals that I'm showing partial parts of their faces here. Just a brief milliseconds, just to illustrate one of these 2 brains that I'm talking about. Trying to guess the celebrity just from a partial picture of their faces. So this illustrates one of these modes, one of these 2 brains that we have inside the skull is exquisitely designed by evolution to pick up bits and pieces of partial information, and then it will process, compare, relate them, and assemble them in comparison and using existing databases. The main goal of this first type of brain that I'm talking about is really to make up a story to allow the individual to respond to a stimulus as quickly as possible, because that stimulus really could be a snake in the grass, could be a threatening animal, or could be a threatening social cue. So this is one of the 2 brains that I'm talking about. The second, very different, operationally speaking, brain that lives in the same skull, obviously, is the brain that we recruit when I ask you to tell me what comes next in this series of objects. This, as you can imagine, is a much more effortful type of brain. It lives by rules, and it really takes more time to accomplish these types of tasks. So in fact, we have at least, but for simplification purposes, we talk about these 2 very different types of brain. One is called the System 1. It's a fast, automatic, and short-term brain. The other one is System 2, which is slower, conscious, and long-term. Recruiting this brain takes more effort. Just to give an example, the idea of this configuration of having 2 brains inside our brain, 2 different operation systems, is not that one is better than the other, that we should be using one more than the other, but a healthy brain really relies on this very healthy, very robust flow of information between the 2 different systems so that the brain can decide and can use the best brain for a given situation, or the best combination of brains for a given situation. Just for example, if I show you a picture, System 1 will jump right out at you and tell you that this is a very interesting, probably speech a woman giving on a flying carpet. As soon as the System 2 hears the word flying carpet, it will jump into action and try to come up with an alternative approach, an alternative story that does not run afoul of laws of physics. So that's one example. Another example, very classic example, is this test called Stroop test. And if I ask you to say the color out loud, just pay attention to what your brain is doing when you're trying to say the colors out loud. And I'll give you a few seconds to run through this card. And pay attention what happens to your brain when I ask you to tell me the color now. So this is a typical task that is used to measure impulsivity, and the thing that I want to highlight bringing up this task is that the System 1 is perfectly capable of dealing with tasks in which there is a perfect match between QA and QB. There is no conflict, there is no ambiguity that needs to be dealt with or solved during the performance of a task. As soon as we inject or incorporate some conflict or ambiguity in the system, in this case when the color of the words do not match what the words are saying, System 2 needs to be recruited and invest some effort and using rules to really come out on the other side with the right answers. And this takes more time. So if you were paying attention and keeping tabs and monitoring what's happening in your brains, you probably noticed that in the second case scenario, you were taking longer to come up with the answer. And that answer was not always correct. So this is a configuration of two operationally different systems in our brains that have been designed by evolution over hundreds of thousands, millions of years. And this system can go wrong or array in different ways. These ways of throwing this system out of balance can be shown in different pathological conditions. Substance abuse and addiction is a typical case in where we see how this balance of forces of brains can go wrong. In addicted individuals, the flow of information can slow down. So the information, the decision-making, the ability of the brain to decide which brain should take care of a particular task can become impaired. The weight or the preponderance, the importance of the system 1 can become supraphysiologically abnormally engorged. And at the same time, as a double whammy, the weight or the capacity of the system 2 to keep tabs on prepotent impulses can become weakened. All these three mechanisms of weakening or breaking the balance between these two systems is into play in the case of addicted individuals. Why is this message in this module important? Well, I think it's important for kids to understand that there are, first of all, that they have two brains, at least two brains, and there are pros and cons to this configuration that was designed by evolution. They need to understand where this balance can go wrong, the things that can threat this balance, and also that this configuration has a very powerful influence on decision making. Perhaps more importantly, they need to understand that these two systems develop at different speeds, which brings us to the second part, the second module in this unit, which is that the two brains, system 1 and system 2, take a long time to mature fully. It's a very protracted process, and they do it at different rates. If we look at this not a longitudinal study in this case, but it's a cross-sectional study, population of kids from age 5 to 20, and these are pseudo-colorized images from magnetic resonance imaging studies of each of these brains. In this study, the pseudo-color indicates maturation, and the bluer a region gets, the more mature. That blue really signifies the density of neurons, of neuronal connections in that particular part of the brain. And this study epically and classically show that the very last parts of the cortex to fully mature are precisely those parts in the prefrontal cortical region that are in charge of keeping tabs on impulses, of planning for the long term, and pondering the consequences of our actions. This means that if you look at an adolescent brain, subcortical regions in charge of impulses, of emotions, and emotional memory really are fully mature in that brain. That makes the system 1 pretty much in most of these individuals on average. There's a tendency for young adults to have the system 1 in charge of this decision making, just because the system 2 is not fully on board. You need to wait until young adulthood, 22, 24, 25 years of age, for the system 2 to really become fully on board and be able to keep tabs and produce, to generate some kind of a balancing force, counteracting force to the system 1. And it's only then when the decision-making process becomes more adult-like and sounder decisions can be made. This explains why young people tend to take more risks. There is nothing wrong about their brains. It's just this differential rate of maturation is built into the way these brains have evolved. Why is this message important? Well, first of all, there are evolutionary roots of risk-taking. The kids need to know that it's not their fault, that they are not to blame for their decisions. There is physiological reasons why they behave they do, and the impact on decision-making, obviously. But this is also empowering information, because there are actions that we can take, both as young people and as adults, designing safer environments to increase resiliency. So talking about this brain development program, the process and how this is so similar or like brain programming is the content, is the topic of the third module in this unit. What's happening, what's going on during this process of brain development? And this is the purpose of this module, is to begin to give kids, children, insight as to the actual processes that are going on, and they have really power to direct. All these decision-making processes, when we're trying to decide whether or not to reach for that 5th or 7th cookie in the jar, they're accompanied by this dialogue that if we pay attention, if we are aware and monitor what's happening in our brains, we can almost hear this conversations, sometimes quite loud conversations between our better angels and our better devils, so to speak, on our shoulders, trying to argue back and forth what we should do. In fact, this humming or this conversation is really the humming of electrons and electrophysiological signals running through all these behavioral circuits that we have in our brains. These are very active when we decide whether or not to get that cookie, whether we are trying to choose between Coke and Pepsi, how we're going to be dressing for the game this weekend, whether or not I'm going to accept that joint that I'm being offered, whether or not I'm going to passing along that piece of gossip that just received. All these decisions, big and small, are really the result of circuitry that is through which electrophysiological signals and impulses are coursing through. So these circuits do not come from factory program. We need to program those circuits and networks in our brain. So if we use this metaphor to understand or to try to explain what brain development is, we can think that an adolescent individual, a teenager, is really a person that is actively programming its brain circuits constantly. Everything that he's experiencing, every class that he or she goes, every piece of music that he or she is listening, all the social interactions, all the movies that they see, all the texts that are received and sent, all that goes into one sort of line of code or another. So in terms of neurophysiology, this programming of a young brain sits on two major pillars, fundamental pillars of a neurological mechanism. One is a short-range connectivity. It's the production of short-range connections between neurons and the connections that they are produced between them. This is a process that mainly involves gray matter in the brain. These are the short-range connections, and the process has been compared to that of pruning, whereby these connections are either destroyed or strengthened depending on the experiences the individual is going through. And the second pillar of brain development or brain programming is that of the construction of long-range connections. This involves mainly white matter because this involves those highways that are made of axon fibers, and they bundle together to connect neighboring areas of the brain or regions that could be quite farther apart within the brain. If we focus on the first process, the short-range connectivity, we're talking about the process of pruning in the brain. And this is important because a newborn, when the time that we are born, there is this massive proliferation of neurons, both cells and connections in the brain. And at some point, the experiences will start pruning those back and create more sophisticated networks in response to those experiences. At the end of this massive proliferation in the brain of a young child, we end up with about 1 quadrillion connections in the brain. That's an astronomical number. And thanks to the experience, playing, relating to parents or to brothers, eating, all those activities that kids are exposed through childhood, pre-adolescence, adolescence, and into young adulthood really bring that quadrillion connections down to 300 trillion. This is the actual experience-driven process of neural pruning. A nice metaphor that I like to use is to think about that quadrillion connections that are produced at the end of the massive proliferation process as the creation of this marble or block of marble that will be the substrate for the experiences to create at the end of the day a sculpture. Now, that sculpture could be a beautiful sculpture or a crappy one. That depends on the type of experiences that this block of marble will be exposed to. The second pillar of development or programming in the brain is that of the laying down of these highways, information highways that connect different parts of the brain with all the other regions in the brain. If we zoom into one of those bundles of containing hundreds of axons, each one of those will be insulated from the outside environment by this sheath of myelin, a molecule that pretty much works like rubber or plastic. We can see in this magnification of the picture individual axons here colorized in blue, and then the myelin sheath that insulates that cable, that copper wire that will send the signals across long distances. These are actually very much like copper wires with the insulating material that allows for very efficient transmission of information. In fact, the speeds that these cables can reach, depending on the function, some of them will be slow at about 2 miles per hour, but some of them can reach up to 200 miles per hour, depending on the job that they need to perform. So in fact, the analogy may not be as good if we use the highway analogy, but this is really like laying down these FiOS cables for our online experience from one home to another through the underground channels in our streets. And what this achieves really eventually is to increase through adolescence the laying down of these increasingly thick bundles of axons connecting one part of the brain with another. Through adolescence, we get this about 3,000-fold increase in the bandwidth of the information. That is, the amount of information that we can send per unit of time is increased several folds during adolescence. So if we were to define what brain development is from the perspective of programming our behavioral circuits, two things need to happen that are driven by experience in a very powerful way. One is the connection of meaningful connections, and that meaning could be good or bad, but they have to mean something for there to be information there. So that's one process. And the other one is the increasing bandwidth to allow for effective information flow between the different units, the different networks that will eventually lead to the emergent properties or complex behaviors that we are typical for. Meaningful connectivity and increasing bandwidth. Now, this programming, and this is very important to know, is goal neutral. We can become very effective at dealing with Fortnite, for example, or other games. This type of processing or programming would tend to narrow our horizons. We will get very, very good at playing this one game. Or we can utilize these pillars of brain programming to expand our horizons and becoming good at all sorts of things in a pleiotropic kind of way, in activities and behavioral routines that allow us to become much more adaptive and responsive to a wider spectrum of related and unrelated activities and respond with much more flexibility to all the things that life throws at us. So the message here is the important thing to remember is that programming, we can make our brains effective at things that matter or very effective towards things that don't really matter. So the important message for kids to understand, and this is why Heidi was mentioning that sometimes I believe that this is the reason I get these standing ovations, is that the message of all this information is that the brains that you get when you're born are really not the full story, are not the end story of your life. You only get a blueprint when you're born, and it is up to you really what you do, what you construct, what you build on top of that blueprint. And this has to do with the decisions that you make on a regular basis. So if we think of that adolescent, the young person, a teen, living through life, getting all these exposures to different experiences, as a person who is programming a computer, programming his or her brain, we can think of all the toxic influences that these individuals will go through life, like malnutrition, bullying, sleep deficits, drugs, physical abuse, emotional neglect, or FOMO, the fear of missing out, for those of you who don't know this new thing. All these toxic influences on that person programming his or her brain are very much like scrambling the letters on that keyboard that that person is using to write subconsciously every line of code. I'll do it again. I love this slide very much. This is the effect of toxic influences like malnutrition or bullying on your ability to write programs in your brain. Obviously, the effects of keyboard scrambling by all these toxic influences are time dependent. If you scramble the keyboard after the program is done, is fully written, that is when you're 25 or 26 years of age, if you smoke marijuana, begin to smoke marijuana at that age, you can expect errors of this type. An error has occurred on the server, please try again later. That means the errors are temporary. The programs have already been written. However, if you scramble the keyboard during the programming, when you are 13, 14 years of age, the types of error that you should expect are fundamentally different. Something like this. The program can't start or run properly because of a coding error. Try reinstalling the program to fix this problem. The problem is that we don't quite know how to reinstall a behavioral program. And that's why prevention is so important, because we don't quite know how to reinstall behaviors in an effective way. And this also explains why psychiatric disorders are developmental diseases. If we take, for example, substance use disorders like addiction to marijuana or alcohol, as you probably, most of you know, there is an exponentially increased risk of becoming addicted to these substances later in life if that initial use, onset of use, happens sometimes around that window of vulnerability between 12 and 22 years of age. And this is because we are scrambling the keyboard we use to program our brains during the actual programming. Why is this important? Well, this is truly empowering knowledge. Kids really need to know this, that the brain that they get when they're born is just a blueprint, and it's up to them where they're going to take that. They can adopt then proactive roles in their own development. And they should become more curious and try to learn about all the many things that can scramble the keyboard. It's not just drugs, of course. It's cell phones, it's lack of sleep, it's all types of drugs, of course, and many, many more things. Which brings me to the fourth and final module in this unit, which deals precisely with all those things that can degrade or harm that programming, particularly in today's world. So this module starts with a discussion of what are our brain programs supposed to achieve. For example, this balanced configuration between System 1, the fast, automatic, and short-term brain, and the System 2, the slow, conscious, long-term. What is evolution trying to achieve with this configuration of two modules? Well, what evolution wants the brain to be very adept at doing is essentially three things. There are three functions that our human brains have evolved to do. One is looking around to identify threats and non-threats. The second module is the module that has to do with food and eating, sustenance. And the third one has to do with reproduction. So this is what our brains are supposed to do, to deal on a regular basis. Second by second, we're either looking around. If you think about your behaviors, you're either looking around or something similar to looking around. You're eating or you're trying to reproduce or behaving in a way, recalling behaviors that have to do with reproduction. This is what our three basic modules in our brain have evolved to do. The problem is that over evolutionary time, and particularly in recent evolutionary times, we are increasingly demanding these modules to do things for which they have not evolved to do. For example, the look around module is now being asked to text while driving. The eating module is now asked to be exposed and deal and manage junk food everywhere. The reproduction module at very young ages is now exposed to things like virtual sex and bizarre porn that is leading to catastrophic consequences. There is this increasing tension then and divorce, a disconnect between biological evolution, which for all practical purposes is frozen in time, and environmental evolution that is increasingly happening at faster and faster rates. And this obviously creates a tension on mental health. That tension leads to obvious consequences like accidents when we're texting and driving, but some of the consequences are less obvious, like chronic stress, heart disease, mental illness, obesity, and addictions. Let me give you just a couple of examples of how this tension between rising because of the disconnect between evolutionary and environmental evolution or changes can happen. We have evolved to seek the fattiest meat, the sweetest fruits, and the most high-energy foods. Why? Because the next famine or starvation phase was always just around the corner. But this is what we have just around every corner in our world, in our societies. And the consequences of that, obviously, are the obesity epidemics that we are suffering in this country, still going on, and in the rest of the world. We have exported that now, and it's a global phenomenon. Another example of this disconnect, we have always been eating fruits in our diets from immemorial times. Thus, we've always been exposed to some level of fermented fruit, thus some level of alcohol. And this is probably why we can handle a little bit of alcohol, either social drinking or wine tasting, you name it, as an adult. We have evolved to handle this level of alcohol, most of us, in our organism, but we have just not evolved to handle these behaviors, this exposure to large amounts of alcohol in the behavior, so-called binge drinking behaviors. Why is this important to understand about this disconnect? We need to help the kids become more curious and help them recognize the threats to their brain's programs. They need to understand that corporations and businesses, they do understand these back doors in our behavioral routines, and they need to be curious and willingly try to learn ways to fight back against these trends in neuromarketing. And we as adults, responsible adults in the room, we need to pay more attention to this circuitry, to these processes, and as a result design brain-conscious environments that make our kids more resilient. So to recap, this module, this educational module that is intended to be given to kids at some point in school and be reinforced with a relevant curriculum, really is based on four basic messages. One is that we have two different brains, that they develop at very different rates. That basic process of development is very much like programming a computer, and that leads to a curiosity, I hope, to understand, identify, and deal with all those factors in the environment, both social and physical environments that can harm that process of programming. Now, behind this metacognition intervention, there is the concept that adolescents, really because of this very high level of plasticity in their brains, is a double-edged sword phase. It is very vulnerable to that impact, to the things that can scramble the keyboard. But on the other hand, that very same plasticity provides an opportunity, awesome opportunities to shape the trajectory, that developmental trajectory in positive ways. That's why I'm not trying to freak anybody out when we are talking about the toxic influence of cell phones, for example. We've been there before, and every new technology that has appeared has freaked adults out. Television and even books have been considered at one point or another as threats and toxic influences in the developing brain. But we need to remember that this phase is really a double-edged sword. We need to understand the neurobiology of these two sides to this equation, and that these very same factors that make us think of the adolescent as a very vulnerable situation, very vulnerable stage, are the very same factors that make the adolescent brain such a very fertile substrate for opportunities. So I think that when we think about these trajectories and these decisions, I would just leave you with the four concepts that I think that should be front and center in our mind when we try to design interventions that help our kids or nudge our kids from a fixed mindset to a growth mindset. I think that we should pay more attention to these four concepts having to do with a sense of agency, confidence, monitoring, and creativity. I think that these are four pillars that focusing on these as goals in our interventions will help us nudge our young people in the right direction when they're trying to go from the dark to the light. I can't hear you clapping, unfortunately. I hope you are. I hope that some of these concepts have been helpful, and I will thank you and stay online for questions if they show up. Thank you very much.
Dr. Baler, that was just, I have to say, both sides of my brain are working really hard to take in everything that you covered. I mean, it's such a rich presentation, and there's so many elements and so many places that that could possibly be places of action and support and advocacy. So thank you. And I know that when folks get this presentation and the recording, that they're going to want to kind of revisit some of the key concepts and of the core elements of the core components of the curriculum. But so thank you for that. And if you're not hearing clapping, I think there's clapping going on across the country. I also, as you know, our next episode in this three-part series is going to be on ACEs, Adverse Childhood Experiences. And I'm wondering if you can tee that up a little bit. We've had some of the questions that are coming in, and one hit it right on the nail. How does trauma affect some of the considerations you presented in this webinar today? And I'm wondering if you could just kind of relate now that information and build a bridge between this this outline of the brain and its development, and then some of the challenges that happen along the way, especially with regard to ACEs.
Yeah, one of the things that really tees up the trajectory of a brain at this particular stage in life, why these young people are so vulnerable in both good and positive ways, is because the young brain is extremely sensitive to stressful inputs coming from the amygdala, and the creation of these very strong links between emotional stimuli and very long-term persistent memories that are created around those painful or stressful stimuli. So these stress processes can really tee up or shape or prime these circuits in the way they're going to be laid out in the future. They can really condition in which direction both good and bad inputs are going to be shaping those circuits. So they set up a different threshold, either in the good or in the bad direction. And stress really is the fulcrum that these ACE events are going to be impacting, typically on a cumulative basis, the future trajectory of the brain. So at the neurophysiological level, the stress response is what's playing such a big role, and we understand quite a lot of that in these results.
And that would be one of those toxic influences that you so well outlined in that earlier component.
Mm-hmm. Exactly, and many of those have epigenetic components because they really, that priming, if you want to simplify the whole thing, really changes the way the neurophysiology responds to stimuli by changing epigenetically the genomic environment, the genomic landscape. This environmental toxic influence really changed the genome through these stressful stimuli, and that's the connection.
Boy, is that interesting. So I think that we have a great question here that kind of will build on that to say, can you share a specific example of programs that you've seen that really do have more of the positive, that positive momentum and that resilience building, and the key core elements of agency, confidence, monitoring, and creativity? I'm specifically, how does creativity? What have you seen out there that a specific example around creativity, or because we? Well, I
would urge everyone to go online either after this or later and watch the TED Talk or any of the talks of Sir Ken Robinson and how our education system is destroying creativity. We are still running an education system structurally that is designed for the industrial age, for the 1930s, 40s, and 50s. And we live in a very different world. And if you pay attention to what we're doing to our kids in schools, in all the public schools particularly, we are not nurturing creativity the way we should. We are not preparing them for a future where creativity is going to be front and center of a successful life trajectory. So that's one thing that is very important to know. And Sir Ken Robinson is the person that is really most eloquently is explaining why we're on the wrong path in terms of our educational systems. Specifically, some of the strategies that I think could be very useful in this domain of nudging kids from one stance to a positive one is bilingualism. It has been shown that bilingualism, or being part of an intensive second or third language program, helps the brain sort of deal with ambiguity and complexity and conflict in a more effective way. Bilingualism is one such strategy. Mindfulness, we don't have all the mechanistic details, but also it appears that mindfulness has a positive impact in helping kids to regain or to nurture, to promote some higher levels of monitoring and self-confidence. In a way, it's awareness, it's being less of a sleepwalker in life, and we adults do that all the time. If you pay attention at the end of the day, what did you do all day? You pretty much, most people can't really recall what they did. We are going through life mostly in a sleepwalking mode, and becoming aware of all the processes that are going in, how we make decisions, why we make decisions, is something that should and could be promoted from early on in life. So things like mindfulness, bilingualism, and sports, particularly team sports, are three strategies that I would like to leave you with that could work in that direction.
Excellent. Thank you for that. That was really illuminating. And I know that we're going to get lots of questions for Sir Ken Robinson's TED Talk, so we will include that in the follow-up email letter, along with all sorts of resources that come from NIDA shop where Dr. Baler works, and resources. There's just so many extraordinary resources that back up both what you've heard today and expand that body of knowledge. I think we're going to end with one more question for you, and Dr. Baler, certainly we've recognized that this present, when you're moving through the development of the healthy brain, that the presumption, and that's just my presumption, is that you've started with a healthy brain, or the possibility of one that may not already be have a condition perhaps like autism or some other kind of condition that would now throws in another challenge to healthy brain development. Can you speak to that, or is better frame the question for me?
Well, I can. It's not my expertise, but I can give you my thoughts. I thought about the discussion is a larger discussion that I put it under the topic or the title of normalcy. How do we define normalcy, and how we deal with individuals that move left or right from that part of the bell curve where 80 or 90% of individuals live? I think that we as a society need to, of course, destigmatize everything that doesn't look normal, and we need to embrace different brain styles, different temperaments, different personalities, even different what we call mental illnesses. What you mentioned, autism particularly, there are many cases in which that particular disease or disorder can be an asset. There are many individuals in the autism spectrum disorder that can perform functions that no normal, quote unquote, people can perform. There is a wonderful book called The Speed of Darkness that if you are pulling a list of things to read, I think that that's a very, very nice book to read about all the benefits and the life experience of people in the autism syndrome spectrum. And that's just one example. ADHD is another example. We are very quick to stigmatize and to medicalize all sorts of styles and individuals that are in a spectrum, in a behavioral spectrum, that we need to learn to embrace and design environments and educational environments and life environments that are more attuned to their needs. We are not one size fits all. And of course, there are situations, there is schizophrenia and many disorders that don't fit anywhere in a normal type of a life course. And you need to develop clinical situations and conditions that support those kinds of individuals with very severe mental disorders. But there is a huge, I would go as far as say that most of what we define mental illness would do much better if we expand our definition of what's normal and what's allowable to function in our societies and what we're doing today.
Well, thank you for that. I think that was just the right perspective and frame to continue this conversation, that oftentimes is what we think is a disability is actually a gift. And so thank you for that. That was very, very helpful to lots of people. Dr. Baler, thank you so much for this time today. We are just you make brain science not only fun, but really compelling and accessible. And we are so glad that you've shared this presentation. We are encouraging folks to share the recording with their own community. The recording will go out to everyone who registered for today's presentation. We also really encourage you to share it with the teens or youth groups in your life, at work or in your congregation or at home. Teens can really, if an informed teenager is a really hopeful thing. We also want to thank each of you for taking the time out of your busy day to learn more about the role of brain development in the epidemic of substance misuse. Again, please share your knowledge, this knowledge broadly, and join us for our second and third parts of our three-part series. On August 9th, we will be dealing with adverse childhood experiences, the role of life experience in shaping the brain. That will be a 1-hour delivery of a curriculum from the University of Tennessee in Memphis, Building Strong Brains, the role of life experience in shaping brain development. And then August 15th, we will take on prevention and practice, building communities that strengthen the resiliency of future generations, and hear from folks who are working in communities and implementing prevention strategies that kind of take into consideration all the knowledge and the science that we've learned about and are continuing to learn about. So thank you. Dr. Baler, thank you so much. Thank you, all of you. Wonderful. And please stay in touch, folks. If you're not on our mailing list and would like to be, you can please email us at partnerships@hhs.gov. And have a great afternoon, and hopefully we'll see you again on the 9th. Thanks, friends, and thank you, Dr. Baler.
Bye. Bye.
Okay, bye-bye.